Okay, can we start now?
Uh, yes, now
Okay,
you are now live. Okay.
okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good evening to everyone. So first of all, okay, sorry, one moment. I need to, one moment. Okay, first of all, I would like to thank the participants for joining this expert lecture webinar on the title of Quality Assurance of Transformer. So this webinar is organized by IEEE Power and Energy Malaysia chapter and IEEE University Kebangsaan Malaysia Student Branch chapter. So this webinar is broadcasted using StreamYard to YouTube on FB Live on IEEE PES channel. So I would like to introduce our speaker is Ronnie Minhaz from Transformer Consulting Services. He will be presenting all walkthrough the QA process of the transformer manufacturing. So okay, so he will discuss about the environmental condition that can be compromised during the manufacturing process that can have impact of the life expectancy of the transformer. So the speaker, Mr. Minhas, he is the founder of the company Transformer Consulting Services, and he has experience working as a transformer designer in Powell's, Canada, and equipment engineer at SNC Levelin, and at Inmax Power as a utility and as a substation lead engineer at McGregor Construction. He is also he has in the transformer manufacturing plants around the world. So besides providing services to the on transformer and consultant, he has been an instructor on training, workshop, conferences, and seminar. So he held various leadership positions at IEEE section level and regular member of IEEE PES Society. And he is also a member of several working group and task forces in the IEEE Transformer Committee. Okay, so before I pass the presentation to Ronnie, I would like to take this opportunity to briefly introduce the IEEE Power and Energy Society, about who we are and where we are going. Okay. Okay, basically IEEE is the world largest professional association advancing technology for humanity. So IEEE, there are 37 technical societies, and IEEE PES is one of it. And IEEE Malaysia is under Region 10, as you can see in the uh, in the Asia Pacific region. So Malaysia is under Region 10. Okay, then the benefit of the becoming a member of IEEE PES is that uh, we can grow and maintain our technical expertise, get connected with other professionals, like collaboration with the industry expert on addressing key technical topics, and also accessing educational resources covering a wide range of important industry topics. Okay, this is these are the benefits that what PES member can get in the PES. So many resources are eligible for the uh, CEU PDH. For example, the online webinar tutorials, on on-site training and workshop, technical journal, and plain talk basic courses for industry novice. Okay, so we have also a PES resource center where everything you need is available in one place, like a tutorial, videos, technical reports, archive webinar, conference slides, and many more. Okay. Okay. So this is the PES Malaysia leadership, the PES Malaysia chair from 1994 until present. So if you are from the, I think maybe some of you are familiar with them. Okay, currently our PES chair is Prof. Hazli. Okay, so this is what activities what we do. For example, we have invited lecturers, conferences, and awards for outstanding engineer linking with industries, activities, and also senior member drive. Okay, and then we hope you can, for those who have not registered as a PES member, then we hope you can join, then get benefit of the IEEE PES. Okay, okay. That is the brief introduction about the PES Malaysia. So without further delay, I will pass the microphone to Mr. Minhaz. So please join me to give a virtual welcome to him. Okay. Okay, Mr. Minhaz. So the
Thank you.
microphone is yours. Okay, thank you.
Thank you. Thank you so much. Thank you everyone for joining. So I would say good afternoon to everyone. So today's presentation is on quality assurance of the transformer. Before I start my presentation, just a quick announcement. During the presentation, if anyone has any question, please type your question in the comment section. Then at the Q&A section, I will read out those questions and I will answer those questions. So today's presentation will be around 45 minutes to 48 minutes. So I'll keep going with this 45 to 48 minutes. Then I will stop and I'll read out the question. So you can type your question during the presentation, or you can type your question at the end of the presentation at the comment section, and I'll read out those questions. At the same time, I will answer those questions. So let's start today's presentation. Uh, as I said, today's presentation is on the quality assurance of the transformer. The first question comes, why quality assurance? What's the reason behind that? What are the purposes of the quality assurance? There are two main purposes of the quality assurance. Number one purpose is operational reliability. The second reason is the life expectancy of the transformer, extending the life expectancy of the transformer. Now, let's answer the first question. What is operational reliability? Let's say when you procure the transformer and you put into the service, you want the transformer to be in service for, let's say, 30 years, 40 years, whatever it is. And during that time, you don't want the transformer to fail, or due to some reason, you don't want to take the transformer out of this service. So that means during that lifetime of the transformer, you want the transformer service without any interruption. That's what we call operational reliability. Now the life expectancy. So what is the life of the transformer? The life of the transformer means the life of the insulation. What is insulation? Insulation is nothing but cellulose. and the oil. Basically, we talk about the cellulose. The cellulose is nothing but carbon hydrogen chain. So now, according to the IEEE guidelines, so one of my colleague at IEEE Transformer Committee, actually he did that with an experiment. Is that the experiment? The result of this experiment was that if you procure a transformer and put into the service, and if you put the transformer into service, and if you do the loading, that full load, and the temperatures are close to the limit, in that case, the life of the transformer would be 7 years. But what we see when we procure the transformer and put into service, we see transformer, especially for the electric utilities, uh, like lasting for let's say 30 years, 40 years, even longer. Sometimes you can see the transformer for 70 years, 80 years. At the same time, for industrial purpose, usually you want to see the life of the transformer like along the life cycle of the plant. Usually, most cases is 20 years. So now, from these 7 years of the life cycle to extend it all the way to 70 years, that's we call it the life expectancy of the transformer. Now, in today's presentation, we will see that during the manufacturing process, what we can do so that we can have a reliable transformer, not only a reliable transformer, at the same time, we can extend the life of the transformer. The first question comes, what can be the causes of the reliability of the transformer? So I was talking to a few of my colleagues over here in US and Canada that work for big transmission companies. What they're telling me is that last 5, 10 years, they've been seeing a quite a surge into the through faults. Through fault means it can be single line to ground fault, it can be any other fault, right? So I asked them, what is the reason behind that seeing this surge of the fault, the through fault last 5, 10 years? What I gathered from talking to them is that actually there are a few reasons that there is rise in the through fault. One of the reasons is that when the line is being built, due to the climate change and few other reasons, there is change in the climate, and the tree trimming process that they have in place is not coping up with the growth of the trees. So trees are growing, let's say for example, due to the change in the climate, sometimes it's unusual to that what the tree trimming process they have, causing those touching those lines and causing those through faults. The second reason that they told me is that as the demand for energy rise quite a bit, with that the complexity of the system increased. Because the complexity of the system increased, it is creating a stress into the system with the rise of the through fault. Due to those reasons, what they are seeing, that they're seeing the equipment they have into the system are being stressed. Then I asked them, so when they're talking about that system, the equipment in the system being stressed, so what about the transformer in the system? What I gather from this research is that especially the transformer that they are from the mid 80s, and now they're being more stressed than the transformer that were being designed and built from mid 80s and before. Now the question is that why the transformer from mid 80s and now are being more stressed than the transformer from mid 80s and before are not being stressed the same way. One of the few reasons behind that. One of the main reason is that especially the transformer that are being designed and built up until mid 80s, that time those who that we work in the transformer industry as a transformer designer, we did not have computer, we did not have those sophisticated computer program and tools to design the transformer. So that's why that time those transformers that being designed, especially they're over designed. Not only over designed, they're also overbuilt. So if you go to any substation, if you look at the transformers that are from 50s, 60s, 70s, even up to mid 80s, you'll see they are big, bulky, and heavier. Because they are big, bulky, heavier, and they're over designed. That's why when those rise of the throughput happens, they are quite stronger to withstand those fault. So that's why they're not being stressed the same level, especially those transformers from mid 80s that we have procured due to the quite extensive use of those sophisticated computer program. Now we are very aggressive into transformer design. Not only that, transformer are becoming more compact and more aggressive in design. So that's why, because we are not looking at some of the qualities that can be compromised during the manufacturing process, those are putting those transformer into higher stress due to those rise in the throughput. Now, what can cause the life expectancy of the transformer? There are two main reasons that can cause the life expectancy of the transformer. Number one reason is a thermal reason. Okay, now the question comes, why there is thermal reason? What can cause this thermal reason? One of the reasons can be during the manufacturing process, if something can block the oil channel, something can block the flow of the oil inside the winding. It can be a blockage into the winding. It can be a blockage into the oil duct inside the winding that can cause the thermal rise. And that thermal rise, what it will do, it will break the carbon hydrogen chain, which will decompose the cellulose, and in a way, it can cause the life of the transformer. Now, the second reason can be electrical. That electrical reason can be, let's say, for example, during the manufacturing process, there is a metal particle or there is dust can get inside the transformer, which can settle down in the long run. And when you apply the voltage, and that voltage can create a ionic path and can cause arcing, can cause some other fault, something like partial discharge and all those things, which is an electrical fault and which can cause sometimes a rise of temperature on those spots, which can cause the life of the transformer. So what we are seeing that there's two main reasons that can cause the quality compromise of the quality of the transformer. One is the operational reliability, the other one is the life expectancy of the transformer. The next question comes is that what can be those reasons during the manufacturing process that can compromise the quality, I mean reliability and the life of the transformer? Let's start with that. The first question comes the factory location. Does it matter whether the factory is located somewhere, let's say in dry area, in compared to the factory is located in a humid area or wet area? Humid or wet means where you can have a high humidity. Or the factory located somewhere near the ocean. Does it really matter? Of course it matters. Let's say, for example, if a factory is located into a dry area, it has an advantage over the factory located into humid area or located nearby the ocean. The advantage is during the manufacturing process, what the transformer will do, it will absorb the moisture from the environment. So just before tanking the transformer unit, so what the manufacturer has to do, they have to put this transformer into a drying process, which we call it vapor phase. So if the transformer absorbs moisture during the manufacturing process, being in a humid area, effectively being in a humid area or near to the ocean, so the transformer manufacturer had to put this transformer into a very extensive, not only very extensive, multiple cycle drying process. Very extensive multiple cycle drying process means is a cost of energy to the manufacturer. So cost of energy is not same around the world. Let's say, for example, the per kilowatt usage of electricity will not be same the price whether it is in Canada or USA or Germany or China or Korea or Malaysia or Indonesia. The cost of energy varies from country to country. So now, if the factory is located in a place where the energy cost is much higher, in that case, the manufacturer will not be competitive into market because when they bid into the market, they have to be competitive on price. So if they have to be competitive on price, in that case, they have to cut corner. One of the things that they can think that, okay, my energy cost is so high, so I may need to cut my cost into the energy. So that means now you see that a factory located into dry area has an advantage over a factory located into a humid area. So now, if a factory located into nearby the ocean, what disadvantage it has? Let's say, for example, in that case, if the salt vaporize from the due to the change in the temperature and the factory is not being controlled, what will happen, those saltiness can land inside the transformer and in the long run it can create an ionized spark which can compromise the quality of the transformer. The next question comes is about, does it matter whether a factory is old or new? Of course, it does matter, especially when the factory is an old factory. First of all, it will not have the layout which is conducive to the manufacturing process. Second thing, most cases it may not have the space at the same time investment into modern equipment. I'll show those modern equipment somewhere down the road into the presentation. At the same time, layout also matters. Now I'll show you an example over here. This is the layout of an old factory. Over here you see the winding area right across the path. Right across the path you have that coal steel cutting area. Right across it you have that coal stacking area. Right across it you have the tanking area. All those areas under one roof, and not they are not being separated. Let's say, for example, winding area is not being separated from coal steel cutting area. Coal steel cutting area is not being separated from coal stacking area. That means if something happens in one area, that can spill over into the other area and can cause the compromise of the quality of the transformer. Here is an example of a new factory. Now look at that layout. You see the winding area is separate from the core building area. Coal stacking area is separate from the core building area. Winding material storage area is separate from the external material area. Test bay is separate from the paint area. By doing so, you can control the environment of the each department. As you can control the environment of the each department, it can help to increase the quality of the transformer. So the next question comes the climate control of the factory, whether the factory is fully climate control or partially climate control or no climate control. And what is the impact of that? Now, when I say fully climate control, let's go back to this layout of the new factory. When I say fully climate control means every single department of this layout is being controlled for humidity, being controlled for temperature, being controlled for dust, being controlled for any kind of metal particle. So when I say partially climate control means, let's say for example, just the winding area or just the coil sizing area or the coil assembly area. Only this area is being controlled for the humidity, being controlled for the temperature, being controlled for the dust, being controlled for the metal particle. When I say no climate control means, let's go back to this layout where everything is under one roof and there's no control of the climate. There's no control of humidity. There's no control of temperature. There's no control of metal particle. There's no control of dust. So those things can compromise the quality of the transformer. So now sometimes when you go to the factory, you may see that they have that air shower. But if you notice very carefully, the air shower, as you went there to inspect, only you are using it, but other employees are not using it. That time the question comes, why this air shower is there? Is it as a show or is it for everyone to use to increase the quality of the transformer? So now, when you go inside the factory, the first question comes the cleanliness of the factory. Is the factory clean or is dirty? Here it says that some study being done, it says that a clean factory can increase the reliability of the transformer almost by 4%. So now when the cleanliness approach comes, there are a couple of approaches. One of the approach is that all employees being part of the cleaning process. When I say all employees being part of the cleaning process means, let's say for example, the person who is in the winding shop area doing the winding. So that person is responsible to do the cleaning in his area or her area. Let's say, for example, when the employees they come to the factory, when they walking inside the factory, when they see something anywhere, if any particle, any dust, they clean it by themselves. That's called all employees being part of the cleaning process. In that case, it is like a team, and all employees knows the importance of having a very clean factory, which can have the impact on the quality of the transformer. Whereas the other approach can be the cleaning can be done by a third party. One of the problems with the third party is that many areas the cleaning is being done by the people who have been doing those cleanliness or in the profession of cleaning for generation after generation, and they do not have any upward social mobility. Not only that, they do not have any training on how they have to do the cleaning. Sometimes what happens, they do cleaning for 1 month, the transformer factory. The next month, they go to the airport, do the cleaning of the airport. The month after, they go to the hospital, they do the cleaning of the factory. So now here, the problem is that during the cleaning, doing the cleaning for the factory, transformer factory, is not same as doing the cleaning for the airport, doing the cleaning for the hospital. So it's very important that those people who are engaged in cleaning the factory, they have to understand the importance of cleanliness into the quality of the transformer. So now here is the flow chart of the transformer manufacturing process. Let's say, for example, a electric utility or a industrial setup. When they're procuring the transformer, the first thing they do that they send out the RFP or bid to all the manufacturer. The manufacturer look at the bid, then they do the quotation design. When they do the quotation design, the user, they evaluate the quotation design commercially and technically. After the evolution of the commercial and technical evolution, what they do, they issue a PO to a specific manufacturer. Once the manufacturer, they get the PO, what they do, they send the design to the design cell or the project cell. In the design cell or project cell, the electrical designer and the mechanical designer, they work parallelly to do the electrical design and mechanical design of the transformer. Now, depending on the size of the transformer, it can take from 6 weeks to 16 weeks to do this design, both electrical and mechanical design. Sometimes some user, they say that, you know what, we would like to do the design review. When they do the design review, after finishing the electrical and mechanical design, they send the design to the user, and the user review the design, and it takes 2 to 3 weeks to do the design review, and then finally give the approval that the design has been approved. From there, the manufacturer move on the procurement process. In the procurement process, they procure the material that will be used for the manufacturing process. Now, when the procurement process finished, the material will start to show up in the manufacturing plant. In that case, the manufacturer, what they do the inward inspection. They have to make sure, let's say whether it's a steel or conductor and all other materials will go in the manufacturing process, they are maintaining certain quality. From that inward inspection, so some material will go into the core building area, some material will go into the winding area. So the material that will go in the winding area, that will be the insulation package and the conductor. So in that winding area, the winders will start winding the coils. Once they finish the winding the coils, what will happen? They remove that coil from the machine and they will put into the oven to dry it. After they put in the oven to dry it to reduce the moisture level from that winding, then what they will do, they will apply the pressure to size the coil. At the same time, in the core building area, they will build the core. Once they finish the core and the sizing the coil, then both core and the coil will move into the core coil assembly area, where the manufacturer will put the coil into the core and they will do the lead work. After they finish that core and coil assembly area work, then they will put that transformer into the vapor phase to dry it. That's what I talked about. If during the manufacturing process, if the transformer absorbs the moisture, then the manufacturer had to put the transformer in the drying process for a longer process, which will cost money. Then once they finish the drying process, then they will put the transformer into the tank. Then they will seal the tank, then they will put the bushings, then they will dress it, then they will move into the test bay for testing. Once they finish the testing, if the transformer is successful in the test, then they will move it, they will remove all those bushings and all those accessories, then they will move the transformer into the painting shop, they will do the final touch of the painting. After they finish the final touch of the painting, they will dispatch it for shipping. So this is basically the process of the transformer manufacturing process. Now I will walk you steps and I will show you what can compromise the quality of the transformer. The first thing, let's talk about the procurement. Over here, I'll talk about the material. The material that the manufacturer will procure, three main components. One is the core steel, conductor, and the insulation. When it comes to the core steel, the manufacturer can procure that core steel in two ways. One is they can procure the pre-cut steel, which will come from the third party, or the manufacturer can buy the steel in bulk and they can cut it in-house. When it comes to the conductor, the manufacturer can procure the conductor in four forms of conductor. Number one, the conductor can be paper insulated and enamel coated. Number two, the paper can be only paper insulated. Number three, the conductor can be only enamel coated, but it will not have any paper insulation. The final one, the conductor cannot have any enamel coatation, cannot have any paper, it can be only bare conductor. Now, when it comes to the insulation, the manufacturer can buy the insulation in bulk, or the manufacturer can buy the insulation as a pre-cut or pre-prepared by a third party. So now here's an example. If you see the picture, the way that manufacturer buys the steel as a pre, or the manufacturer can buy, in the left picture you can see the steels in the roll. That means the manufacturer buying those steel in a roll in bulk. When they buy those steel in bulk like this in the roll, in the right hand side picture you can see a core cutting machine. They put that roll into the machine and they cut those steel in this machine. Now the problem with this core cutting machine is that when they cut the steel, it will create the metal particle. Now let's go back to this layout that I talked about right over here, the old factory layout. You see the winding area, right across that winding area, you have that core steel cutting area. And this winding area is not being separated from that core steel cutting area. Now imagine you have that in that core steel cutting area, you have this machine over here, right over here, the right machine where you have that steel being cut. So what can happen is this metal particle can fly from this area to the winding area and can land in the winding. The thing is that there is no test. In the factory acceptance test, you cannot pick it up. Not only that, usually when you procure the transformer, those compromise of the quality will not show up in the first 5 to 10 years. Usually it shows up after 10 years. So that means you are basically see those disruption to reliability or the reduction to the life, especially after 5 to 10 years of the transformer into service. So now here is an example of the conductor that being used in the transformer. The left one is we call it CTC, and the right ones are we call it magnet wire. Now look at those conductor. The gray paper are insulated. What are those gray papers? Those gray papers are nothing but carbon hydrogen chain. So now during the manufacturing process, you know, when you have this conductor insulated with this paper being exposed to the environment, and if that environment has high humidity, what will happen? This carbon hydrogen chain will absorb the moisture from the environment. So now over here is an example of a conductor with the insulation. Now the insulation can come into layers. Here you can see 1, 2, 3, 4, 5. This conductor has 5 layers of insulation. I'll give you one example over here. I'll talk with you an example. Let's say, for example, I was working with one of my clients. They bought 3 transformers in last 5 years. The first transformer they bought 5 years ago. That time we did the design review. When we did the design review, that time the manufacturer said that he's going to give us 60 millimeter paper insulation. So now, 3 years ago, we did the design review for the second transformer. That time, the manufacturer said that he's going to give us same transformer, same voltage class, same rating. The manufacturer said that he is going to give us 50 millimeter insulation. So now the third transformer that we are procuring this year, at the beginning of that year, back in January, we did the design review, and the manufacturer said that he is going to give us the paper insulation 40 millimeters. See, within the 5 years, the same manufacturer reduced the paper insulation from 60 millimeter to 40 millimeter. And there is no way you can pick it up by factory acceptance test. So what is going to happen, this reduction of this 20 millimeter within 5 years, is going to put in a stress into the quality of the transformer. Now, not only that, when he reduced the insulation to 40 millimeter, he said that in this 40 millimeter, I will give you in this 5 layers. You can see in this picture right now, 1, 2, 3, 4, 5 layers. Now, 40 millimeters in 5 layers. That means if you divide 40 by 5, each layer is 8 millimeter. So that means when you're getting this conductor with this 5 layers, each layer is 8 millimeter, 40 millimeter insulation. Now, if I force the manufacturer instead of giving me 5 layers, if I tell that no, give me instead of 8 millimeter 5 layers, give me 8 layers with each layer 5 millimeter. That means I'm splitting this 40 millimeters into 8 layers in each layer 5 millimeters. That means if you look at from the electrical point of view, from the physics point of view, you are basically increasing the capacitance. Increasing the capacitance means increasing the electrical strength. Increasing the electrical strength means you are increasing the reliability of the transformer. So that can happen that you cannot pick it up with any test. Let's say, for example, you cannot pick it up during the factory acceptance test. So now, let's go back to the slide. So now, as I talked about, the manufacturer moved from 60 millimeter to 40 millimeter within 5 years. So I asked the manufacturer, why did you do so? What the manufacturer said that when 5 years ago, when they were giving us the 60 millimeter, that time their design philosophy was they took the breakdown voltage for the paper was 40 kb per millimeter. Now, after 5 years, right now, in their design philosophy, they changed their design philosophy. They moved from 40 kb per millimeter for the paper breakdown voltage to 50 kb per millimeter paper breakdown voltage. So now here's the thing. Here you see there is one, two, three, four, five, six, seven different type of paper. There's crepe paper, there's cup paper. So now what kind of paper I'm going to give you into the insulation, conductor insulation, it depends on how much I will give you. It depends on what is the breakdown voltage the manufacturer is taking for the paper insulation. So now, as you see, this paper is nothing but carbon hydrogen chain. During the manufacturing process, this carbon hydrogen chain will absorb the moisture. The next is beside this, you can have this insulation, which we call it spacer, which is nothing but carbon hydrogen chain. Again, this carbon hydrogen chain will absorb the moisture during the manufacturing process if the factory is located in area where it has higher humidity. Now, beside that, you can have more carbon hydrogen chain inside the transformer. You can have strips, you can have a molded component, you can have cooling ducts, you can have line shield, you can have the rider. Those components are nothing but cellulose. Cellulose means carbon hydrogen chain. This carbon hydrogen chain, what will happen during the manufacturing process, not only will absorb the moisture, it can pick up dust, it can pick up metal particle, which can compromise the quality of the transformer. So now here is a more carbon hydrogen chain. Here you can see the cylinder, you can see the end ring, you can see the key spacer. All those things will be inside the transformer. And those things, if they are exposed during the manufacturing process to the environment, it will absorb the moisture from the environment, which can compromise the quality of the transformer. So now, as I talked about, let's say, for example, those over here, all those things I'm showing, those are pre-cut, come as a pre-cut from the third party. The manufacturer can say that, you know what, I will not gonna buy those things as a pre-cut from the third party. What I will do, I will buy those insulation in bulk and I will use this shop, we call it insulation shop in-house, and I'll cut those insulation in this shop. Now the question comes is that this shop, look at the floor, if the floor is clean or not. If this floor is not clean, what will happen if this room is not climate control? If this room is not humidity control, what will happen? This insulation will absorb moisture and it will pick up dust and all those things. This absorption of moisture, this pickup of dust, you cannot identify those things by any test. What will happen? Those things in the long run will cause the reliability and life of the transformer. Basically, it will cause the compromise the quality of the transformer. So now here's an example in what is special. Let's say in the left picture, you see this blue wrap. What is this blue wrap inside this blue wrap? In this blue wrap, inside this blue wrap is nothing but pre-cut steel. Not only pre-cut steel, the steel is oil soaked. Now the question is why the pre-cut steel is oil soaked and wrapped it like this. The reason behind that, let's say for example, if a transformer manufacturer is located into Malaysia, near by the ocean, and Malaysia being in a region, in a area where it may rain during the monsoon season. Now, if it happens that this pre-cut steel is being shipped and exposed to the environment, and monsoon rain happen, it can pick up those rainwater. Not only that, it can absorb the moisture during the shipping process, and if it absorb the moisture, what will happen? The steel will be rusted. If the steel is rusted, it will compromise the magnetic property of the steel inside the transformer. Now, in the top right-hand side picture, you have a hole. You see the hole into the conductor reel. If that reel is being shipped, and during that time, if the humidity is high, it will absorb the moisture from the humidity. Not only that, it can pick up the dust, it can pick up the metal particle during the shipping process. Not only that, if it rains, rainwater can get inside this reel through this hole and can cause the compromise of the quality of the conductor. Now, at the bottom picture, you see that the manufacturer, if the manufacturer bring those steel in a roll and cut it in house, see, they're putting those things in the floor. The floor is dirty. Not only that, it is being bented. Not only that, it can create a scratch into those steel, and those things can compromise the quality of the transformer. One of the things that I go, let's say for example, I have the experience of going all big major factories around the world. The first thing I do when I go inside the factory, I usually take a powerful magnet with me. I use this magnet and roll it in the floor, and I pick up those magnetic particles. You may have the question, why, from where those magnetic particles or iron filing coming inside the factory? One of the things that I have noticed that inside the factory, they usually don't have maintenance procedures of all those equipment, especially the crane. If you go inside the factory, if you look upward in the roof, you will see the factories, they have big crane to haul those transformers from one department to another department. When those cranes are running, if the proper maintenance are not being taken, those cranes, what will happen? The bearings, the gear will be wear out and create those iron fibers and iron particles that fall inside the factory, which can compromise the quality of the transformer. Here is an example of the core building area. The top picture is a factory, in the old factory where they don't have any modern mechanism. You see that how the core is being bended. In the bottom picture, you see in a new factory where they use modern technology, modern equipment to stack the core. Look at the difference. If your transformer core is being stacked using the modern technology, using the modern tools, like the bottom one, where there's no bending into the core, there's perfectly stacked. So of course, it's going to increase the quality of your transformer. The next here is a picture of a core I took in one of my factory visits, where let's say what happened in that factory overnight. It rained. Next the morning when I went to the factory, because overnight it rained, the humidity shoot up, and what happened? The core got rusted due to the high humidity. What will happen? This rust that you see in the picture, it will stain the core, and when you energize the transformer, it will compromise the magnetic characteristic of the core in a way which will compromise the quality of your transformer. Here's an example of a winding shop. So in a winding shop, you can have the winding machine, vertical winding machine, or you can have the winding machine, horizontal winding machine. These two pictures are shows the example of horizontal winding machine. So if your winding is being winded using the vertical winding machine, it's much better being winded by the horizontal winding machine. Why? When you wind it by using the vertical winding machine, in that case, the gravitational force G will be on your side, and you can make the winding much tighter against the cylinder. One of the main things that you have to look at when you want your transformer quality to be increased is how tightly the winding is being winded against the cylinder. Is there any gap between the turns? Is there any gap between the sections that can allow the winding to move around when there is a true fall happens into the system? So in the top picture, you see in the old factory where you have that horizontal winding machine and there is no braking mechanism. This winding is being done by the human using the human hand. So when human is doing the winding using the human hand, in that case, it will not be tight enough against the cylinder. Whereas the bottom picture, you see the conductors that coming out from the reel, it is going through the braking mechanism. Right after the braking mechanism, you see that the conductor is much tighter against the cylinder. Not only that, at the top of that cylinder, you see a tensioner. So you are using the braking mechanism and the tensioner with this modern equipment. If your transformer is being winded, in that case, of course, it will increase the reliability of your transformer. Here is an example of a vertical winding machine. The left one, you see the vertical winding machine without any braking mechanism, without any tensioner. Whereas in the right-hand side picture, you see the vertical winding machine with the braking mechanism with a tensioner. So if your winding is being winded using this vertical winding machine with the braking mechanism and tensioner, in that case, of course, it will increase the reliability of your transformer. Here's an example. On the left-hand side picture, you see I went for an inspection of a winding, and I noticed there is a big hole. The hole is so big that my pen even go inside that hole. Now, what can happen? As I talked about at the very beginning of my presentation, that the electric utilities are seeing the rise of through fault. So what happens when you see the rise of the through fault? The through fault, when it gets inside the transformer, it will create the short circuit force. When the short circuit force creates inside the transformer, it will shake the winding. When it will shake the winding, if you have a space like this inside the winding, the conductor will move around in this space. When the conductor will move around in this space, it will cause the failure of the transformer. So in that case, that means if you have a transformer being winded in such a way that it is creating all those gaps, it is going to compromise the quality of your transformer. Now on the right hand side, you see in the right hand side picture, you see some duck stick sticking around at the top. Initially, what happens when they wind it into the machine, I could not see those sticks. So once they remove this winding from the machine and put it in the oven to extract the moisture, once it come out of the winding, the oven, they applied the pressure. When they applied the pressure, the winding shrink almost 400 millimeters. So that's why you can see those sticks sticking around. When a winding shrinks like 400 millimeters, just imagine mechanically how strong it will be. Of course, it's going to compromise the mechanical strength of your conductor, of your winding. That means it's going to compromise the quality of your transformer. That means having a factory in a place where it is higher humidity, that means it's going to absorb the moisture, and during the winding process, you have to shrink it. That means shrinking it means you are compromising the mechanical strength. So now in the left-hand side picture, you see that they prepared those coil. On the right-hand side picture, once they prepare that coil, they will land that coil into the core. So when you land that coil into the core, if the transformer factory is not climate controlled, if it is exposed to the environment, what will happen? Those grating, the insulation will absorb the moisture. If the grating absorb the moisture, it will expand. If it expands, that means in that case you will have problem landing this coil into the core because it will be much tighter. So now once you land these things into the core, then when you put it to the vapor phase, what will happen? It will extract the moisture. When it extracts the moisture, it will shrink. When it will shrink, now it will create a big gap between the core and the coil. So now when you have those throw fault, it will create the short circuit force. When it will create the short circuit force, it will shake the conductor, it will shake the coil. So that means it will be much more prone to the failure of the transformer. So now in the left hand side, you see a picture from an old factory where they are doing the brazing of the lead by using the old method. Old method means the gas welding process. When you do this gas welding process, it's going to create those particles. What will happen to those particles? That can land inside the transformer and can cause the failure of your transformer in the long run. Whereas in the modern factory, on the right hand side, what they use that induction machine. When you are using that induction machine for the brazing, you're not creating any fume, you're not creating any dust, you're not creating any particles. So that means it's going to increase the quality of your transformer. Now here you see an example of a transformer before it and starts into the vapor phase. So look at the size of the transformer, how big it is. Now all those gray things are nothing but cellulose. Cellulose means is a carbon hydrogen chain. Now you see in the stage, if your factory is not climate control, what will happen? It will absorb moisture, it will absorb the dust, it will absorb all those metal particles. From this stage, it will go inside to over here, which we call it vapor phase. Now here's the question comes. Vapor phase means the manufacturer will use the kerosene vapor to extract the moisture from this. To extract the moisture from this, the bigger it is, the more exposed it is to the environment, the more moisture is absorbed from the environment. That means the manufacturer has to put this transformer into this chamber for longer period. Longer period means it can be from anywhere from 3 days to 7 days. So that means, let's say, for example, if a factory is located into drier area, in this case, manufacturer maybe has to put this transformer into this vapor phase for 3 days. If the factory is located into the wet area, in that case, the manufacturer had to put it for 7 days. That means 4 days extra. 4 days extra means 4 days of energy cost. Is a cost for the manufacturer, and the manufacturer has to be competing to market for price. So once it comes up the vapor phase, now they put into the tank, then it goes into the test bed for test. So now the question is that, can I pick up those things that I talked about that compromise the quality of the transformer in the manufacturing process? Can I pick up any of those things in the test bay during the factory acceptance test? Of course not. One of the, let's say, for example, if the manufacturer is aggressive into design, let's say, for example, if they did very aggressive design, and what they can do, they can use a pure refined oil inside the transformer, which has the higher breakdown voltage, and the transformer will pass the FAT. Let's say, for example, if the transformer picked up any dust, any moisture, so because he is using the pure refined oil, not only that, the factory environment is controlled environment, is not the field, that environment that the ambient temperature change quite a bit. So because it's in controlled environment where the manufacturer is using pure refined oil, so it's very easy to pass all those tests that you cannot pick up any of those quality problems that I talked about during the manufacturing process. So one of the things that when you go to the factory, the manufacturer says, oh, you know what, we have an ISO certification. The question is that, does it matter whether the manufacturer has ISO certification or not? If the manufacturer showed you the ISO certification, does it matter? You know what, to be honest with you, no. What matters to you is that what is the condition of the factory? What is the QAQC process of the factory? Let's say, for example, whether they have a check and balance into that QAQC process, whether they have a documented process, whether they have auditing process, whether the auditing is done by an internal auditor or external auditor, what they do, those auditing report, you need to look into those things. One of the things that I have noticed going to the factory around the world, sometimes the manufacturers are very reluctant and resistant to issue any non-conformance report or NCR. One of the things, the reason behind that is that the manufacturer thinks that if they issue multiple NCR, when somebody comes for factory audit and when they see a lot of NCR, they think that the factory has a problem. So that's why the manufacturer has resisted to issue any NCR. Not only that, they always try to hide their problems and try to show them the user that, you know what, the factory has the highest quality. You have to be careful onto those things. Not only that, when they use the subcontractor, suppliers, what kind of QAQC process they have in place for supplier and subcontractor. You also have to look into what kind of training process they have. Do they have continuous training process or occasional training process, or do they have no training process? Not only that, when they have the training process, are they doing the training only for a specific task, or at the same time they're doing the training also something like, for example, professionalism, something like work ethics, something like concept of service, something like how to deal with things. Are they have training those kind of things? Here's the things I have the experience. Let's say, for example, going around the factories around the world, there is a huge contrast. A factory being located in Germany, a factory being located into USA, a factory being located into South Korea, a factory being located into China. What is the difference? One of the things that, let's say for example, a factory is being located into a place where it is part of the industrialized society. Not only industrialized society, having a history of 100 years, 50 years, 60 years of long history of manufacturing. In that case, those places have a very qualified workforce. Not only qualified workforce, they have a work ethics. They have, let's say, for example, a structured a manufacturing process. Whereas, let's say, for example, if you go and establish a factory into a place where it's never been part of the industrial society, it used to be part of the agricultural society. All of a sudden, you put a factory there, you cannot expect the same level of work ethics. You cannot expect the same level of workmanship and concept of service in this place. So there is a huge contrast. Not only that, there is also culture becomes into play. Let's say, for example, you went to a factory where you found something problem into the factory and you brought this thing to the right person's attention into the factory. In that case, the factory can say to you that, you know what, thank you so much bringing this to our attention. We'll work together with you how to improve this. Not only that, we will make sure that in future we do not have the same issue again. At the same time, there can be, due to the cultural reason and due to other reason, there can be another approach that you went to the factory and you found something and you brought these things to the attention of the responsible person, and the responsible person completely ignoring you and pretending that there's no problem with the factory. Not only that, blaming you that you brought something that is not acceptable. So this blaming game, the service of concept, also contributes to the quality of your transformer. Now the question comes, what can be the Bible solution for those things? The Bible solution can be, you can add up some of those things. Number one is factory auditing. Number two, design review. Number three, QAQC inspection, holding points. Let's talk of those things one by one. Number one, factory auditing. What does the factory auditing mean? Factory auditing doesn't mean that going to a factory with a checklist and ticking the checklist. No. When you go to the factory, try to engage someone who has a transformer design background, who has the experience of transformer factory, working to transformer factory. Not only that, who comes from a very conservative design background. So when that person goes into the factory, that person, let's say for example, going to the electrical design area, then he will talk with the designer that, hey, look, if I'm going to approve your factory for next 5 years to supply the transformer for my company, let's say it is TNB or Sarawat Energy, right? So what are you gonna do? What will be your philosophy? Are you going to take 40 kV per millimeter for breakdown voltage for paper insulation, or are you going to take, let's say, 50 kV per millimeter for breakdown voltage for your insulation? What will be the breakdown voltage for your oil? Are you going to take 25 kV per millimeter or 30 kV per millimeter? Because those things will influence whether the manufacturer are going to be aggressive into their design for you or not. And write it down those things into your factory auditing. Let's say you went to the inside the factory, you went to the winding area, you went to the core building area, you went to the core stacking area, you went to the internal shop, you went to the external shop, and you notice that the factory is not being climate controlled. Put that things into your report, factory auditing report, that the factory is not climate controlled. You went to that inspection area, material inspection area. You notice that the material inspection area, they do not have good quality control process. You notice that the conductor reel has a hole, right? Put it into the factory auditing report, right? Put those things. Now you go to the design review stage. Let's say, for example, what does the design review mean? You have someone helping you. You force the manufacturer, when the manufacturer finishes the design, electrical and mechanical design, you force the manufacturer to provide you the design, and you tell the manufacturer, don't buy any copper, any steel, or any other material for this transformer until I approve your design. So when you get the design for the manufacturer, look at the in the design review, you basically look into the thermal design, you look into the dielectric design, you look into the you look into the clearance and all those things, and you look into the short circuit design. So basically three main components: thermal, dielectric, and short circuit. You look into these three designs, you look at the calculation of those manufacturer, what kind of calculation you look. And at the same time, you look into the factory auditing report. If the factory report said that the manufacturer promised you to take 25 kb per millimeter for the oil, 40 kb per millimeter for the paper, in that case, in the design review stage, you look at the design and you see all those clearance and paper thickness taking, is it like 40 kb per millimeter and 25 kb per millimeter or not. Let's say, for example, when did the short circuit design, let's say, for example, look at those, like what is the stress, what is the strength. And when you see those things like satisfies you need, then you approve the design. Now you can go into the, let's say, for example, you can have QAQC inspection, you can have core and coil inspection, you can have core nesting inspection, you can have pre-paper facing inspection, you can have pre-tanking inspection, you can have factory acceptance test witness, you can have inspection prior to the shipping. Now that depends on which one you will take, whether you're going to have all six inspection or you're going to have four inspection, or whether you're going to have three inspection, depends on when you have done the factory auditing, that time what you have noticed in the factory. If you notice that the factory is not fully climate controlled, you notice that there's metal particle all around, there's dust all around, the humidity is like going through the roof, in that case you may consider to do all those six inspection. So now I will share with you one more things that one more item, just to show you that, like, over here, when you go to the design review, you may not be able. Over here, I'm showing you a transformer specification from one of my clients. Over here, look, notice over here what I am saying. Item number D, what I marked it. It said all conductor paper insulation CTC shall be at least 30 mils. Why we put these things into the transformer specification? The reason is that, as I talked about last 5 years, the manufacturer moved from 60 millimeter to 40 millimeter. There's no way that we can pick those things up in the factory acceptance test. So what we do, what we learn into the factory auditing, what we learn in the design review, what we learn into the factory inspection, what we learn over the period, if we see that there's no way we cannot control by factory acceptance test or any other way, what we do, we put into the specification. Let's say over here, same thing happened for the conductor insulation over here. I'll show you another example that we put into the specification that we learned it from our experience. Let's say, for example, over here, we put the maximum current density at ONN rating shall not exceed 2 amps per square meter. What does it mean? It will force the manufacturer to design the transformer in such a way that the thermal means average winding rise will not be close to the temperature limit. One of the things that if we can force the manufacturer to design the transformer more lower temperature, what will happen? We are going to extend the life of the transformer. So by doing so, we are increasing the reliability of the transformer, increasing the life expectancy of the transformer. One more thing I will show over here, I will share that you may not be able to pick up into the test. Over here, especially last 5 years, we are seeing more we are seeing more what do you call, we are seeing more uh, um, leakage of transformer tank. The leakage is coming basically from like not having rigorous inspection, rigorous test, right? So what we are putting the leakage test much rigorous, right? Those things we are putting into the specification that can compromise the quality of the transformer. So what I'll do, that's just basically my presentation today. Now I'm going to open up the question and answer. If anyone have any question, I'm going to answer those questions. So the first question is, how do you find transformer manufacturer improve their QA process based on your inspection experience? Well, here's the thing. Uh, To be honest with you, like it depends. The manufacturer, they're under price pressure, and uh, and uh, and one of the thing is that, like, I have noticed there is a huge difference into philosophy. Let's say, for example, the philosophy of procurement of transformer in the United States, America, and Canada is different than the procurement process in, let's say, in Malaysia. Let's say, for example, TNB, the process they TNB use, or India, or Germany, or any other country. One of the things I noticed, there is a huge contrast. In USA and Canada, what we do, we do not ask the manufacturer to provide certification of ISO that way, or provide the certification of short circuit test. So what do we do? We do the factory auditing, we do the design review, and when we go to the factory, when we see that the manufacturer is not improving, so we force the manufacturer to make the design more conservative. Let's say, for example, when we go and see factory auditing says that the manufacturer did not improve into their QA process. So in design review, what we say the manufacturer, look, we are not comfortable with your 40 kb per millimeter paper insulation, or 30 kb per millimeter for the oil. We want you to reduce that from 30 kb per millimeter to 25 kb per millimeter, or 20 kb per millimeter, which is going to increase the tolerance of the limit. By doing so, we make the manufacturer to make the transformer design more conservative. That's one of the approaches that we use. But whether that manufacturer improve the QA process or not, it actually depends on who they are. It's hard to say. Next question. Is there any other question that I can answer? Is there any other question? Well, if you can't think of any question right now, you have my email address. You can always email me your question. I can always answer your question by replying your email.
Yeah, I think attention to the participant. If you have any question, you can put in the chat box in the FB Live or in the YouTube. Okay.
Okay, the question is, do you have a statistic transformer lifetime reduction due to defect in manufacturing process? Well, to answer this question, actually, there's no statistics. I will answer this question this way. So I used to work for a electric utility. I have the experience of working as a transformer designer for a manufacturer. At the same time, after that, I switched my career from transformer designer to a equipment engineer for electric utility. So what I have noticed in electric utility when I was working as a equipment engineer, so in our fleet we have transformer. We had 40 substation, and we have transformers. Uh, uh, 8 years old transformer all the way to 2 years old transformers. So uh, over the period, let's say some transformer, let's say the question comes why the transformer that we had lasted 80 years, and at the same time we had issue of tank leaking. Some of the transformer, that newer transformer, some newer transformer failed due to short circuit, right? And to be honest with you, like there is no statistics like this, but as I'm being part of a transformer committee, as I mentioned to you, one of my colleague who is a chemist who has done research on that, what he showed in his research is that if you put the transformer into service, if you load it 100%, continuous loading, if the transformer temperature average winding rise is close to the 65-degree rise, your ambient temperature is close to the max 40-degree max. In this case, the life of the transformer will be 7 years. So now, why the life of the transformer will be 7 years? So what happens if the transformer, if the temperature inside the transformer goes above 120 degrees C? The IEEE standard says that for if the transformer temperature goes above 120 degrees C, for every 8 degrees C, you lose the life of the transformer by 50%. Why by 50% is because we call it, the term we call it the carbon hydrogen chain that it has, the chain carbon hydrogen is called, we call it polymerization. So decomposition of this chain happens, we call it polymerization. So polymerization increases. When the polymerization increases, what happens, the paper, it loses its tensile strength, it loses its dielectric strength, and it loses the life of the transformer. So there is no statistics like this. I'm not aware of any statistics, but what I brought to you in this presentation, we never thought it that way before, but we need to think about that. The reason behind that is because with the use of computer program, we are very aggressive in transformer design. Not only very aggressive in transformer design, transformer is becoming very compact and aggressive. So when transformer is becoming very compact and aggressive, but at the same time we are not improved into the manufacturing process, so that's going to compromise the quality of the transformer. That it can cause the life of the transformer. But what I can say from my experience as working as an equipment engineer in the electric utility at the center, working as a transformer designer, is that you will not see those things within the first 5 to 10 years of the life of the transformer. Usually the transformer start to show up the symptom after the 10 years, depending on how you load the transformer, what is your loading process, and what are the environmental conditions. Let's say, for example, what's your ambient temperature and all those things. Thank you. The next question. Yeah, thank you. Thank you for your compliment. Yeah, thank you. Thank you, Mom. I think,
Okay.
MC, yeah,
Yes.
yeah,
Ronnie, may I have a question?
yeah, sure, go ahead, please.
Yes. I just okay. I sometimes got some question from my colleague. So from the user perspective, what can user do to uh, to oversee the I think the quality assurance of the transformer manufacturing, because the user is I think the result or the effect or the impact that will affect the customer, the plant.
Okay, let me take few minutes to answer your question. I will answer your question. My own experience, actually, last year I was 6 months in China. I lived 6 months in China last year, and before that I lived in India for 1 year for project, and before that I was in Colombia for 4 months, Mexico for 4 months. So let me talk with you from my experience of last 3 4 years staying in those places for projects, and I will share with you what is the approach in America and Canada they take. It may help people. So here is the thing. So when I when I moved from a transformer designer in the manufacturing industry to the electric utilities as equipment engineer. So my manager called me up. My manager said that Ronnie, so today you are starting your new job. So before you started the new job, I want to give you an assignment. He said to me that Ronnie, you'll be responsible. You'll be the responsible person for the all procurement of all transformer for our electric utility. Then he said that why don't you take a week and do your research, and let's have a meeting, another meeting after 1 week, and discuss that what we can do to ensure that we can have a better quality transformer. So what I did that week, so I make a list of how many transformers we have, what transformer we have in our all substation. I made a list of every single transformer, which year it was built, who is the manufacturer, which factory from the world it came from. And in this history, let's say whether it is a 70 years old transformer, in the 70 years, whether we had any problem with this transformer. So I made a list of every single transformer that we had in our list, in our fleet. Then I met with my manager. I told my manager, look, we have 40 substations. In these 40 substations, we have 170 transformers. With this 170 transformers, we have transformer as old as 80 years and as new as 2 years. We have transformer coming from all over the world, from all those major manufacturers. So now I asked my manager that when I'm going to procure this transformer, first of all, at the same time, I looked at the specification. I told my manufacturer that what you want me to do. Do you want me to buy the transformer to take all those steps that I needed to take to ensure the reliability of the transformer and the life expectancy of the transformer? When it comes to the life expectancy of the transformer, I asked my manager that I see in our fleet we have transformer as old as 80 years, as new as 2 years. So now, as I am going to be in charge of procurement of the transformer, so you want me to buy this transformer should last 30 years, should last 40 years, or should last 60 years? What do you want me to do? So my manager told me that, Ronnie, I want you to procure the transformer that will be last at least 60 years. Not only that, we want the transformer in this 60 years, we want the reliability, 60 years reliability of this transformer. So at the same time, my manager told me that, so we are going to procure this transformer, they're going to last 60 years. So you have to make sure in the procurement process, you do all those due process so that we can reduce the cost of maintenance of the transformer. Reduce the cost of the maintenance means we're going to reduce the corrective maintenance, preventive maintenance. So that means I had to do something in my specification. I have to do something into the procurement process so that I'm going to have the transformer will be last 60 years. Not only last 60 years, it will give me a 60 years reliability without any major failure. At the same time, I'm going to sit with my supervisor, maintenance supervisor, so that how we can work with my maintenance team so that we can reduce the cost of the maintenance from the corrective maintenance and preventive maintenance. So what we came up? So we came up that, okay, if we have to procure the transformer, if we allow, let's say, for example, this manufacturer, this manufacturer, this manufacturer, this manufacturer to bid for our project, so we see that we may have issue with that, this design with this manufacturer. Let's say, for example, this specific manufacturer is aggressive in design. This specific manufacturer doesn't have a good factory. This specific manufacturer doesn't have a good quality control documents. So that means if we are going to allow only 5 manufacturers to bid for our project, so first things I need to know who are those 5 manufacturers, who they are, and what's their capability, what's their weakness, and what's their strength. Based on that, we tuned our specification. Number one. Number two, based on we adopted factory auditing process. Not only that, we adopted design review, we adopted the inspection process. Not only that, we put into the clause, into the specification that if the manufacturer does not comply with our quality assurance process, not only that, does not cooperate with our inspector that will go into the factory, then the manufacturer will be responsible for any liquidation damage. That's the approach we take. Actually, that's the approach also we take in United States and Canada. Whereas what I've noticed in the rest of the world, when they do those procurement, I do not know whether they have the discussion, the equipment engineer has the discussion with their manager that, you know what, if I'm going to procure the transformer, what should we look into? Should we look into reliability? Should we look into the life expectancy of the transformer? I do not know whether they ask those questions themselves. And based on that answer of those questions, whether they work on their specification, whether they hire someone or take the help of someone who is very knowledgeable in this field. At the same time, have a participate into, let's say, for example, participate into technical seminars like this, participate into forums, let's say, for example, Transformer Committee, IC Committee, SIGRE, or IEEE Transformer Committee, or something like this, or seminars to know that what is happening around the world so that they can ensure that they're adopting all the best practices that in the world in their procurement process. So that's my answer to your question. I hope I answered your question.
Okay. Thanks, Ronnie, for the comprehensive answer. Okay. Okay. Is there any other question left? Okay. I think okay. We almost come to the end of the webinar. Yep. I think yes. This is a very interesting topic. So okay, hopefully if there is any other question, you can directly send your question to Mr. Minhaz. And then I would like to thank Ronnie for answering the question. And also I would like to thank to the participant for joining this expert talk as well. So now we have come to the end of the webinar. I hope you can get benefit from this webinar and continue supporting IEEE PES Malaysia in the future events. Okay, so once again, thank you, Ronnie, for presenting.
And thank you, everyone, and thank you to the host for hosting this event. And also thank you to the person behind that who are doing all those what do you call the high-tech IT work. And thank you, that in gentlemen too.
Okay, okay, you're welcome. Okay, so hereby I will end this webinar and then I will close this webinar. So thank you everyone for attending this webinar. So please stay safe and keep healthy. Okay. Assalamualaikum warahmatullahi wabarakatuh.